The biggest thing that we've seen driving demand at the moment is AI. If you look at what's happening in the world, it's really, really incredible the way that it's progressing. But this does give us some challenges in the data center facility space. The rise of these large AI models and computing demand has given a massive rise in what we need to do and the facilities that we need to provide. Gone are the days of the 2 and 3 kilowatt per rack for this kind of compute power. They are upwards, and they're talking upwards of 100 kilowatts per rack in terms of certain AI models, that what they need to for the compute. So as you can see, I mean, if you look at just what has been happening in the recent past and what we feel taking the trends that have happened, we're looking at 1 megawatt DCs being needed, and not necessarily very large, but very high density power. So it's driving exponential growth in the data center sector, and we estimate a need for around 75 gigawatts over the next couple of years, which is an incredible amount in regards to that. If we look at what the challenges are, time to market, this is going to be a very big challenge because everybody wants to get to market now quickly. So it's creating quite a lot of demand. The urgency to deploy these, the fact that existing data centers don't have the capacity or available spare capacity to cater for these massive jumps in power per rack, that has led to a much higher power density. The other thing is around reliability, and I'll chat a little bit later around that, and the different types of problems that we're experiencing over the last couple of years in data centers and what causes them. So let's have a look at one of the first things, which is high demand. Time to market, getting the data center out there. The problem with using existing white space is that not being catered for high demand on the AI space. The high power rack density requirement has not been planned, and it is driving a demand to put together data centers at a very fast pace. If we look at some of the information that's provided from some of our surveys and studies of the market, there's a demand of over 30,000 qualified people worldwide right now in deploying data centers, of which there's about a 60 to 80% shortfall in that demand of trained people that can provide. And it's a case of there are a lot of people that are trained, but because the projects are now piling on top of each other, they're not able to do all of them all at once. So we have to look at how to reduce the time to market. We have to look at dependencies, lessen those dependencies on the workforce, make it easier for the workforce for less people to do more, and improve the material supply efficiency. The power demand is one of the biggest challenges, the rapid increase in power demand per rack. And in Africa, we have primarily looked at DX cooling as our main cooling source. We do have obviously options on chilled water. It has not been as prolific as what DX is, the ease of install, the ease of maintenance, and that kind of thing on the DX side. But on the DX side, we have got limits, and we are seeing a massive drive into a hybrid type system demand, because there's just so much that DX or air cooling can do versus what liquid cooling can do. And I've certainly seen a lot of talk and articles around the development of different cooling technologies, whether it be submerged cooling, whether it be on-chip cooling. And these are all very, very new technologies in the grand scheme of things, because while they've been around for a little while, they unproven. So we need to look at how we develop these products and develop them correctly and quickly. The mix of air cooling and liquid cooling has become quite a big hot topic in regards to that. And it's due mainly, as you can see there, to the types of CPUs that are being deployed. The fact is they can mass stack these servers in racks, and the power density just grows and grows. The next area that I'll discuss a little bit is about green power. We have seen a massive upscale in governments around the world signing accords, signing into law, signing that there is a massive drive for renewables, clean energy, that kind of thing. It is really taking the world by storm at the moment in that regard. And I mean, just a few examples here. The demand that data centers are looking at in just, how can I say, applied for already is quite a lot at 25.9 gigawatts that has to be approved for manufacturing. I mean, Malaysia's 2.1 gigawatts of applied for power density. London 1.3 gigawatts, Seoul 1 gigawatt needs to be deployed fairly quickly. And with the increased challenge of governments signing agreements around green power and renewable energy sources, the way to provide that power is becoming a good challenge as well. Some of the places, I mean, they're in Europe, they want green power proportion in data centers to be 100% in Europe by 2030. And in China, they're saying that their hubs will be 80% green by 2025. These are stiff challenges that we have to face and cater for. So things that we need to look out for are especially around the renewables. The last thing that I'm going to say before I move on around the challenges is the faults. Obviously, we've seen, look, we know that there have been faults happen. These things that they don't just happen for no reason. We've done lots of extensive studies around that and looking at what causes it. And as you can see, some of our information that's provided is quite interesting, especially in the root causes for DC faults around the data center. If you take a look, 71% faults are around cooling and power, and then 39% human error related. So obviously, power and cooling is a massive demand for getting the right product, getting a reliable product out to the market, and making it more reliable for our clients in that regard. So, I mean, I'm sure quite a few people have heard of the term dark data centers. That's something that's been thrown around for many years now. Data centers that don't need human interaction for fault locating, for finding out or for tracking errors, for fixing problems is the only time somebody goes in there. So it creates a data center that operates primarily in the monitored space and is dark. So the nice thing about that is that technology is evolving all the time to help us develop these and push for the ultimate dark data center. So reducing the impact of human errors in the field. So, I mean, you look at the expanded scope of DC faults that was over the last year has increased quite a lot. But what's interesting is the expected impact that AI will make that in a 10 megawatt data center 123 times greater impact on the amount of users if a fault happens in an AI DC versus a standard DC. To summarize, one of the things that we have to look at as an OEM and a company that develops solutions for this is some of the things that we have to do is fast deployment. This is quite key. Flexible cooling, green energy, and obviously increasing the reliability of the product. This is a key factor. And one of the things that we are also seeing is a rise in the number of companies that are deploying data centers in multiple areas. So we need to look at how we can support those data centers. As an OEM, this is very important. And in that regard, Huawei has done a fantastic development of their ecosystem, and I will go through that a little bit more. We are looking at typical, if I take a look at fast deployment, we're looking at typical times that we want to achieve of between 9 and 12 months deployment of a data center, traditionally 2 years. We're looking at flexible cooling. I mentioned about what DX can do and how we can take DX only so far. Then we need to look at other alternatives like liquid cooling. Green energy is a huge demand, and that has driven a lot of developments in that regard. And obviously reliability, it has to be there. With this, we've developed a range of products for the data center facility we feel fit into these spaces and address these conditions. One of the first things being modularity. Huawei had took this very early on in their journey to develop modular solutions rather than traditional monolithic or monoblock solutions. And we really put a lot of effort into developing these modular solutions. And in that regard, we've done for the data center modular solutions as well as modular components. So we can, and we have got a lot of experience in this already. We've deployed over 80,000 UPSs and 300,000 lithium batteries into this area already. Prefabricated systems, manufacturing, prefabricating, testing before going to site. Very big factor in reducing the time needed to do testing on site, to deploy on site. We can concurrently, while we're manufacturing and prefabricating the product, we can develop the civils on the site, have them done, and at the same time while the manufacturing process is going on, which makes a much faster deployment in that regard. And that helps reduce the time taken to complete the data center and move into the test phase and eventually the deployment phase of the data center going live. So we are targeting that 9 to 12 month period, and we've done it many, many times over. With over 2 gigawatts of power pods deployed, 5,000 plus cooling modules, and obviously then we look at high quality product, 90% being pre-installed and commissioned in factory, which helps to eliminate any errors on site, especially when it comes to hard to reach sites or sites that are in Africa, a challenge to get spares to straight away if there's any on-site problems straight away at deployment, dead on arrival, those kind of things. So pre-testing, prefabricating becomes a very big part of our ecosystem. This reduces the time to market by up to 50%. Then we also have to look at the cooling solution. Mentioned the hybrid factor that DX, which is typically primarily deployed into Africa, which we use mostly, but we need to now also bring in the liquid cooling aspect and new cooling technologies like the on-chip cooling that is available in racks. So we have developed a hybrid system that can now be deployed and provide this for sites in both the DX deployment as well as liquid cooling in areas where it's needed. And we can dedicate areas to AI technology with this kind of deployment, making it far easier to maximize the usage of the space, the white space in the data center. But we also needed to make it simple. We couldn't have it complicated. And again, this is where modularity comes in, making modular components that make it easy to deploy and easy to maintain. So simple architecture and high reliability is very high on our list of priorities. And ultimately, I've mentioned this a few times around reliability. This is something that Huawei takes very, very seriously. I will show you shortly. I mean, the amount of investment that we put back into our R&D makes us a leading company in that field of research and development. When it comes to design, we talk about our smart lead packages, which is our power storage for UPSs using lithium-ion battery storage. Smart lead, 10-layer protection. So we make sure that the products are very reliable. The fault redundancy, the modular design, again, modularity comes into play. Very easily maintained, very easily checked, very easy to replace when something does happen. Makes it very reliable and very favorable. The test and certification, Huawei spends an incredible amount of time and effort getting international certification and testing our products to the nth degree before deploying into the market. I've personally been around to some of our test facilities, and they are top-notch facilities that do state-of-the-art testing for products, for longevity, for reliability. What can they withstand? It's sometimes amusing to see how hard they try to break the product and how much effort they put into break the product so that they can understand where to improve components to make that even more reliable than the norm. And then we make use of AI cells, AI prediction for key components, using data that's been obtained over the last 15 years in deploying products into the market, in monitoring products in the market, in monitoring products in our own use data centers and our own areas. Gives us a very, strong process to develop algorithms so that we can predict the lifespan of key components like capacitors and the UPSs, like the electronically controlled fans, the variable feed fans, monitoring them, understanding what factors will influence degradation of those products. This is very important. So even ourselves using AI, we've seen a massive demand in ourselves in deploying these AI type environments. This is something that I have been talking about quite extensively, which is our R&D investment and our continuous innovation for these products. We employ over half of our team in the digital power space that are R&D engineers doing research and development over 12 R&D centers located all around the world. And it is amazing to see the technologies and the innovations that they come up with. And this is an illustration of the different products that we have developed and deployed in the market so far. We look at smart power supplies on the left, talking about our power pod, which is a fixed power stack that can be containerized or on a skid, ready for a data center, right from the transformer to the branch circuit deployment, providing the entire power link from on the low voltage side, which is a very nice product in that regard. Smartly batteries I spoke about. When we look at the cooling, the different types of cooling that we've developed for specifically around data centers, like our EHU, our indirect evaporative cooling, and also our fan walls, available in multi different technologies like liquid cooling or like chilled water and DX. Our prefabricated modular DC, our fusion module, our fusion DC 1000C, which stackable, high density power available, and makes for deploying state-of-the-art data centers very simple. On our indoor solutions, we've got our fusion modules, both from a single rack right up to pods of up to 48 racks, RT racks in them. These are products that have been extensively deployed at the moment. Our fusion solar products, whether it be our smart string inverters or our battery storage products that have been deployed. And then again, as always, our monitoring and maintenance platforms, our smart management systems that ultimately aim to bring us around to a dark data center. So with specific algorithms put into it, like and deploying products like our cooling and our power technology in those smart management systems. These are all products that have worked, that are being deployed and being developed constantly for the huge demand being placed on data center facilities as we move into this AI era. So how do we achieve this? To recap how we achieve this, we are operational in over 50 countries in our digital power space with design standards compliance. We've deployed 3 million plus DC cost data volume, meaning that we've tracked over data that for over 3 million data centers, whether it be right from the small server rooms to large scale data centers. We've got experience in project design, 900 plus megawatts, extensive design and drawings that we deploy for our customers, and concept designs in less than 2 days for specialists data centers. So ultimately, our end-to-end design management team is one of the world's leading DC design centers, and this helps us to provide these services to our customers in that regard. This is just an indication showing you the areas where we do cover. We have a global service covering 170 plus countries, 1 hour service radius at our flagship service centers. I mentioned we have 12 R&D centers in the digital power space alone. We provide global technical support with over 1,800 professional employees, engineers deployed into these call centers in over 170 countries with up to 14 languages being supported. And we currently doing spare parts support in over 500 cities with advanced replacement arrival in 4 hours if needed on tight SLAs. As I mentioned there, the flagship service centers close to customer sites, we can bring down that SLA to 1 hour where needed. It is something that is at the heart of Huawei, is service to our customers. We've always been customer and partner centric. That is our core, one of our core beliefs, and this has served us very well in growing and developing a company like this. Some of the acknowledgements that and people that we use and partnerships that we have in order to meet these demands is listed here. The message that I would love to convey across to you all is to understand that we are a global player in this market with extensive experience and extensive partnerships with the top players to develop product that is covering exactly what is needed in the market. So yeah, thank you very much. As I said, if there is anything that you want to discuss specifically or reach out independently, please click the links provided to get more information, and I'll be happy to assist if anybody wants to reach out individually. I'm going to sign off and say thank you very much once again.